Hi, my name is Tiffany, and today my team and I will present on our computer science capstone project, the cochlear implant hearing practice app called HearBat. My team consists of Aaron Mai, Henry Sides, Long Lam, Luke Walker, Ryan Sharma, and Tanner Blake, and it's sponsored by Tim Anderson. And a brief overview of our project, it is an app that helps cochlear implant users with hearing exercises. So the motivation behind our project is that there are over 1 million cochlear implant users around the world, our sponsor included. And when you get a cochlear implant, you need to retrain your ear of how to hear again. And a lot of apps that help you practice hearing again, they lacked accessibility and had poor user experience, and they were often paywalled. So this is why we created our project. And here is a quick demo of it. This is our HearBat app. Upon opening the app, you're taken to the sound check page where you can make sure that your volume is adjusted to your liking and that you can hear it. Once you click ready, you're taken to the home page where you can see our different types of exercises, whether you want to train words, sound, speech, music, or even build your own custom module. If you click on profile, you're taken to the settings page where you can choose your language, feedback sound, whether you want it on or off, and also the accent for the language that you chose. So now I will demo to you the train words options, but it will work the same between words and sounds. Words, you will hear words. Sounds, you will hear different types of sounds. So I will start with the beginner foundation. Once you click on it, you will see 4 different circles. When you click on a circle, you will get in some context about what the circle means. So for this case, the first circle is Module 1. You also might notice here that we have 3 different indicators. These indicators are just meant to show you that you got a high score on this exercise. Every time you score 8 or more on an exercise, one of these will get colored in. And I'm going to click Start, and we're taken to the difficulty settings page. So you can choose your difficulty setting, voice type, background noise, and noise intensity. So if I click on a noise intensity and a background noise, I can preview what it sounds like before starting the exercise. And when I'm starting this exercise, I will get 1 right and 1 wrong to show you the differences.
Super Bowl.
And I will do this one correctly, and you would hear a chime. And I will get this wrong, and you will hear a different sound. And you also have the option to hear what you chose versus the correct answer. So once you complete the exercise, you get your score out of 10, and you also see the highest score that you've got on this module or on this exercise. You also see the words that you missed and review them. And this is the same for the sound exercises. And then for speech, this is practicing hearing and then repeating what you hear. And I'm just going to start it.
Take the last cookie from the jar.
Take the last cookie from the jar. And then it will show a percentage of how accurate you were, rather than a distinct score like previous exercises. Here we have the pitch resolution exercise where you can see if notes are higher or lower, and basically distinguishing notes. And I'm going to click this to hear it again. Upon finishing the pitch resolution exercise, you will see all the sounds that you missed, and here we show the semitones. So 8 semitones means that was the difference in the 2 notes that you heard. The higher the number of semitone is the higher the contrast in the notes, which means it's easier to distinguish. We also have a custom module builder where you can create your own. I created a test set here, but we can always edit it after we created it. I'll just add another set. And don't worry if you only have ideas for 1 word, because once you save it, we will autofill the rest for you. So here you can see we added 3 new words. We also created an insights page. The green circles indicate all the days where you have practiced. And here you can see your speech accuracy, and this is all daily, by the way. And if you do the speech exercise multiple times a day, it will just display the average score of that day. And here we have a progress bar of how much you've practiced for the day, as well as your streaks. You can view your most missed words ever here, and as well as most missed sounds, but we didn't do sounds exercises at all, so that's why it's blank. So now down here we have our speech accuracy over time. I wiped the data for the purpose of this demo, hence why you only see one date here. But as the more you practice, you will start seeing a trend line of how well you do over time. And then our streak feature on the demo, since this is just an emulator, is also off because we hard-coded some false data just for testing purposes. But if you click on that streak icon widget right here, you will be taken to our streaks page, and where you can see your longest streak as well as all the other days you've practiced and for how long. And we also completed our Vietnamese version. So if you can now switch to another language, and the whole app will translate to Vietnamese. And this goes along with the content as well. So our speech to text and text to speech is also in Vietnamese. And we also created content for it as well. So you can see here, all the exercises are now in Vietnamese. We also refactored the code in a way that it makes it much easier for future developers to add new languages if they wish. I also forgot to mention that for streaks, we also have push notifications to remind our users to practice every day.
Hey everyone, I'm Henry, and I'm going to go through the top features we added to HearBat. These are multi-language support, an insights page, a new exercise type called pitch resolution, and additional gamification components. For multi-language support, we built out the old app's infrastructure, making it way easier to add new languages, and then added Vietnamese by translating all in-app text to Vietnamese and setting up speech-to-text and text-to-speech. Our new insights page allows users to track their stats across their time using HearBat. Some stats displayed here are days practiced, time practiced, streak progress, that user's most missed words or sounds for those respective exercises, their speech accuracy, and their overtime speech accuracy for that exercise. Our new exercise type is pitch resolution, and it allows a user to test their hearing in a musical context. How this app works is the user is provided with 2 notes, and they are tested on if the second is higher or lower than the first. For our added gamification components, we added user streaks and push notifications to motivate users to practice more and increase their engagement. We added indicators to show how well one is doing on a particular exercise, and this progress bar, which is based on their time practiced. Now, those were the 4 main top features we added, but we also made a ton of other changes to the app. We got a lot of comments on reducing the friction of working through the UI, so we made a lot of UI changes. Some of these were fewer widgets to click, so the user has to spend less time tapping through all the different screens, provided additional context and descriptions for exercises, and shortening certain settings pages to make sure that they could fit on just one phone screen or as close as we could get. We added new voice settings for each exercise, so a user can choose between a male, female, or randomly switching between them for each exercise type. An additional feedback chime noise on successful answers. And we also improved the cache management behind the scenes and revamped our custom modules feature. So if given more time, we would add additional modules for the music exercise. We only had time to add 1. We would change the exercises or add new ones to allow for progressing difficulty or dynamic difficulty. Let's say one user is going through an exercise for words, they're doing well, maybe the difficulty gets harder. If they're doing poorly, the difficulty gets easier. Expand more languages, which is super easy with that refactor. It would just take a little bit of time to translate all the in-app text. And more gamification elements. We talked a lot about adding cosmetics for our bat or for the UI in general, which we didn't get around to.
Hi, my name is Aaron Mai. I'll be talking a little bit about HearBat's architecture today. So I want to first talk about the technologies we use. So we use Flutter, which is a framework that is a wrapper around Swift and Kotlin, the native iOS and Android languages. And Flutter is really nice because you're able to just write the app one time and then build for both of those platforms, saving us a lot of time because we don't need to write the same app twice in those languages. We use SQLite for our database, which allows us to store our users' progress. And we use Firebase Crash Analytics to know if an error occurred after we deployed it. And then we also use Firebase push notifications to notify the users of any notification that we decide to do. And for the GCP functionalities we use Gemini in order to dynamically generate a module based on the words that a user has already inputted for a custom module. We use the Google Cloud Speech API to transcribe what the user spoke for a speech module, and then transcribing that speech into text in which we can score. And then we use the Google Text-to-Speech for those speech and word modules. And next, I want to talk about our caching system for the word and speech modules. So on the first time a user loads into a given word and speech module, the JSON file of pertaining to that module will be fed into Google Text-to-Speech, which will generate an MP3 for each word or sentence for that given module. And these MP3s are then saved on the local phone, on the local storage. And then when you actually go into a module here, you see on the right, those local MP3s are to be played instead. So the advantage of this is that, one, we don't need to call the Google Text-to-Speech API every time you want to hear a word. So this saves us a lot in cloud costs. And secondly, the user doesn't need to wait for that response time of the Google Text-to-Speech API call. So this drastically reduces the latency between when they expect to hear a word and when they actually hear it. So here in the bottom, you can see that for the subsequent times, the phone just uses the local MP3s that were previously cached. Okay, so now I'll be talking a little bit about the higher level view of the architecture. So here in the left here, you can see the words and speech cache that I was talking about in the previous slide, which uses the local phone storage to save those MP3s. And for the word and speech modules, we use the cached MP3s here. And for the sounds and music modules, we have already downloaded all the sounds that we need when the user first installs the app on their phone. And for the speech module here, you can see that we transform the speech into text in order to score it. And after the user is done with a given module, the results are then saved to the database, which the insights page here pulls from. And that's it for me.
Hi, I'm Luke, and I'm going to be talking about the development process. So we utilized an agile methodology with 1 week-long sprints. We met weekly on Discord to discuss the current tickets, assign future tickets, and discuss implementation and design ideas. We used GitHub for our code repository and Jira to track our tickets. Each ticket had 4 stages. It started in to do, then moved to in progress, and once it reached code review, then the developer would send a GitHub pull request to the Discord, and then Tiffany or another team member would review it, and if it's adequate, then merge it with the main branch and move the ticket to done.
Hi, my name is Tanner. I'll be going over the roles and responsibilities that each of us took on while working on HearBat. Firstly, Tiffany was our team lead. She's primarily responsible for communicating with the sponsor and keeping the team in the loop with what was needed in order to stay on track and accomplish the goals that we had set. Second, Aaron already had experience with the HearBat app, so he served as a go-to source of info for the team. If we are unsure on how to approach an issue, he usually knew how to solve it. Henry mostly worked on multi-language support and translations for all the modules in UI. And then Long worked on the Insights page UI and providing feedback to users about the exercises. And then Luke worked on stat tracking for the app so that users could track their progression. Brian worked on refining certain modules and generating content for the new pitch resolution exercise. And then lastly, I worked on creating and implementing the new pitch exercise and adding a daily streak system into the app. In addition to all of the bullet points, everyone worked on smaller bug fixes and refinements as necessary. Rather than separate into concrete roles, we found it beneficial to stay flexible and work on tickets as they came up.
Hello, my name is Ryan. I'm going to go over some of the unexpected issues we ran into in our development. Yeah, so we initially submitted our app to the App Store and the Play Store. It was also rejected from both for crashing. We heard back from the Play Store first, and they said our app was crashing. Obviously, when we were testing our app through virtual devices, and some team members had physical devices that we were testing them on. It didn't seem to crash, so we resubmitted the build, and it was accepted that time. The App Store took much longer in responding, but they also had the same bottom line that the app was crashing, and so they rejected it initially. We resubmitted, and they accepted it that time. So we're now on the App Store and the Play Store. As for user feedback, we were getting issues that the app was crashing, and also that there was UI components that either weren't rendering or at all, or just not rendering correctly. We overlooked these initially because most of our testing was done on virtual devices, which didn't correspond or weren't like a perfect one-to-one to physical devices. So we had some team members who had Android devices that were able to test the UI changes that we made to ensure that everything was working correctly. We also had some requested UI changes that we had to focus on. So that set us back in our development by a little bit when we had instead of worked on other features.
Hello, so my name is Tim Anderson. I'm the client for the HearBat CS Capstone project for this year. And so let me share a few thoughts. So first of all, I had the opportunity to share this project and show it off to a team of specialists at a conference held just last month in Innsbruck, Austria. And so these were industry professionals that specialize in hearing implant rehabilitation. So there were over 100 people coming from over 20 different countries that practice this in this same issue around the world. So I had a chance to show off this app that the team's been working on, as well as to demo it for a team of developers that make an app from the Medell company called Redi, R-E-D-I, that is, while freely available, is not open source. And so they have a large team of developers working full time on this app. And I was able to use insights from working with this team here to also suggest to them usability improvements. The development team was very impressed with what the students had accomplished, and think that this project has the potential of continuing onward. So with that, I'm going to show a few vignettes of things from the app, just so you can get a view as to what it does. And so a background again, this is an open source hearing practice app for people that receive cochlear implants. When somebody receives cochlear implants, they have to do hearing practice. They should really do this. It's akin to the idea of physical therapy after somebody gets a knee replacement or hip replacement surgery. And just as the physical rehab for that is really important, it should also take a priority and be done in the case of hearing practice, but it can be a more interesting activity here. So this is the only currently active open source app in this platform space that I am aware of. This is an example of a common exercise that is done. In this case, the user enters this activity, they press the play to hear the sound, and a word is then played for them using AI text to speech, using a variety of different settings, both male, female, accent, language, and also allowing the overlay of different background noises. So this exercise already existed, but was received continued tweaking and debugging. For example, an improvement in the background noise implementation. The AI speech-to-text exercise also received a cleaner user interface and continued improvement. And so this one implements a whole sentence that is repeated to the user and then scored in here based on accuracy. And so the exercise will go ahead. It shows progress indicator across the top and uses basic speech to text, which would have been very challenging 5 years ago. The team has implemented a nice job using current AI tools to make this work and be manageable. So hats off to them. This is an example of a new exercise the team implemented. So I asked the team to add to the types of exercises. This would be beneficial both for having more activities to do, as well as to provide examples of what new exercises could look like and be used within the platform. It also meant the team had to think about generalizing the architecture to allow for a wider variety of exercises. In this case, it is pitch discrimination where a sound is played and then a second sound is played. The challenge is to identify if the pitch is rising on the second sound or if it is going down. So is the second note higher or lower than the first note? And again, this can be a challenging exercise for people with a cochlear implant, such as myself, where the resolution that we have is not very fine-grained. I mean, I have 12 electrodes on the cochlear implant side that it is using to try to differentiate in here, which provides some limits on the ability to discriminate on the pitches. So in terms of general overall feedback, the team worked hard on creating a more robust platform to keep building upon. And so that's been a challenge. I mean, when building a tool like this is to not just build it for the current problems, but to build a platform that others could readily contribute to in the future. They made user interface improvements. In fact, some of their user interface improvements are ones that the Ready app, despite being older and having a full-time development team working on, really could learn from and try to adopt some of these improvements. They added new exercises that hadn't been implemented in HearBat before. They squashed some long-standing bugs, and they're wrestling with the challenges of getting it up on the app stores, Android and Apple. And so, and those create their own challenges. So once again, great job to the team. It's been a pleasure working with you on this, and I look forward to seeing where things continue going in the future. Great job.
Hi everyone, this is Long. I'm going to be going over the lessons learned for this project. The first lesson we learned was how to collaborate as a team and reaching out and asking for support when needed. So this meant each week we would touch base to discuss tasks for the upcoming week and assign new ones, while also checking in from the previous week to see where everyone was at and whether they could take up new tasks for the upcoming week or not. The second thing we learned was how to manage stakeholder expectations and how to minimize scope creep. So this meant communicating with Tim and letting him know what things we could accomplish and what things we could not do given the limited time frame, and be on the same page with where the app should be from start to finish. The third thing was being proactive and asking clarifying questions. So this meant letting Tim test a new iteration of the app when it was available and asking clarifying questions as needed. Finally, we each gained app development skills and we learned how to translate sponsor requirements to tangible app features. So this meant learning how to use tools like Xcode for Apple, Android Studio, and Firebase when adding new features and while testing the app to ensure that it was working properly on as many devices as possible. And then also learning to ensure that every app feature we were adding met the sponsor requirements each week.
This concludes our video. I want to thank Tim Anderson for sponsoring our project. Thank you for watching.